Hello guys, welcome back. Today we are going to start with derivatives of a composite function. This is the second part of the differentiation series. Now we also refer to it as chain rule. Now first of all, let us understand what a composite function is. Now for example, if I take f of x as sin x and g of x as log of x, then f of g of x is called a composite function. F of g of x meaning this x in f of x gets replaced by g of x, right? And so which means sine of x will become sine of log x. So sine of log x becomes a composite function. Let us see how we derivate composite functions. So let's take the same example. So if y is equal to sine of log x, then the derivative of y, dy by dx, is given by, now what you do is you go from out to in. So first of all, you see sine. So the derivative of sine is cos. So you just simply write sine of log x, the derivative, as cos of log x. But then you have to also go inside. And so you write multiplied by derivative of what is inside. So derivative of log x. So cos of log x as it is multiplied by what is the derivative of log x? The derivative of log x is 1 by x, and that is how you do the composite functions. Now we'll take one more example before we start with the problems. If y is x plus 2 sin x raised to 4, then the derivative of that, dy by dx, will be given by, this whole thing is raised to 4. So we will treat this like how x raised to 4 is derivated. X raised to 4 is 4x cubed. So simply you bring this 4 down and this whole thing, x plus 2 sin x, gets raised to 3. But then you have to again multiply by the derivative of what is inside. So into d by dx of x plus 2 sin x. Yep. And the derivative of x is 1. The derivative of sin x is cos x. You keep the constant aside, so it becomes 1 plus 2 cos x. So the answer becomes 4 into x plus 2 sin x the whole cube into 1 plus 2 cos x. Now let's come to some problems based on composite functions. I mean, these two were as good as two problems, but now let us officially start with the problems. So the first question, y is equal to root of sine of root x. So when we differentiate with respect to x, we get dy by dx equal to, now root is what you see outside. The outermost layer of this function is a root. You know that the derivative of root x is 1 upon 2 root x. So the derivative of root of sine of root x will be 1 upon 2 root sine of root x. What is inside the root? It's sine of root x. So we got to derivate sine of root x. Remember, what we have just derivated here is this root. So now we have to go inside. What do you find inside? Sine of root x. Now sine of root x, the derivative of sine is cos. So we will simply write cos of root x. But what is inside sine? There's a root x. So we go and multiply by derivative of root x, the derivative of which is 1 upon 2 root x. So the overall answer will be 1 upon 2 root sine of root x into cos of root x into 1 upon 2 root x. You can very well multiply this 2 with this 2 and make it 1 upon 4 root x into root of sine of root x with the cos of root x in the numerator. But that's just a case of simplification. This is as good as the answer. Then let's come to the next problem. Next problem, you have y is equal to sine square of x raised to 5. It means that it is sine of x raised to 5 the whole squared. This raised to 2 is simply whole squared. So we are going to treat this whole thing as something raised to 2. So when we differentiate it with respect to x, we get dy by dx equal to this 2 simply comes down into this whole thing, sine of x raised to 5 is raised to 1, and then you go inside into the derivative of sine of x raised to 5. Now the derivative of sine of x raised to 5 becomes cos of x raised to 5. So we got to go further inside into d by dx of x raised to 5. So we get this 2 sine x raised to 5 into cos of x raised to 5 becoming sine 2 x raised to 5. How does that happen? That is 2 sine theta cos theta is sine 2 theta. 2 sine theta into cos theta is sine 2 theta. That's the trigo formula. And obviously the derivative of x raised to 5 is 5x raised to 4. I hope that is clear. Now let's move on to the next question. Question number 3. You have y is equal to 1 upon root of 2x square plus 5 plus root of 2x square minus 3. Now there is a plus sign between two terms, and that too in the denominator. We have done such kind of similar expressions in class 10, where we multiply by the conjugate of this term. Basically we are rationalizing. We are getting rid of the roots by multiplying by the conjugate. So what is the conjugate of root of 2x square plus 5 plus root of 2x square minus 3? It is root of 2x square plus 5 minus root of 2x square minus 3. So we multiply and divide by that. So the numerator into 1 is simply as it is, but the denominator is like a plus b into a minus b, which will become a square minus b square, which means the roots will go away. You'll get 2x square plus 5 minus, and then you'll get 2x square minus 3. What does that give you? 2x square minus 2x square in the denominator is cancelling. 5 minus of minus 3 becomes 5 plus 3, which is 8. And so you are simply left with this numerator divided by 8. Now how do you differentiate this? So when we differentiate this, you will keep this 1 by 8 a constant aside into derivative of the first term, root of 2x square plus 5 minus derivative of the second term, and then this becomes the derivative of a composite function. So 1 by 8 outside, this becomes 1 upon 2 root 2x square plus 5. You follow the root x formula, so 1 upon 2 root 2x square plus 5, but into derivative of what is inside the root, which is 2x square plus 5, minus the same way 1 upon 2 root 2x square minus 3 into what is the derivative of the term inside, so d by dx of 2x square minus 3. So the derivative of 2x square plus 5 becomes 4x. Similarly here also, and obviously the constant derivative is 0. This also becomes 4x minus 0, so that's 4x here. You cancel this 2 with this 4, you get a 2x here. You cancel this 2 with this 4x, you get a 2x here. You take that 2x common, and that 8 will get cancelled with this 2, and you get a x by 4 outside. And what are you left with inside the bracket? 1 upon root of 2x square plus 5 minus 1 upon root of 2x square minus 3. Moving on, come to question number 4 now. You have y equal to tan of x raised to 4 into 4 raised to x. So let's differentiate that with respect to x. So the derivative of tan, you remember, is sec square. So tan of this whole thing will become sec square of x raised to 4 into 4 raised to x into the derivative of what is inside. So derivative of x raised to 4 into 4 raised to x. So this term remains as it is, multiplied by. Now this is actually a UV, a product of two terms, so there will be a UV rule applied. So x raised to 4 into derivative of 4 raised to x plus 4 raised to x into derivative of x raised to 4. You write sec square of x raised to 4 into 4 raised to x as it is. This becomes x raised to 4 into 4 raised to x log 4. You follow the a raised to x formula. 4 raised to x into log 4 plus 4 raised to x into x raised to 4 derivative is 4x cubed, and that is how you solve it. Come to the next problem, question number 5. You have y is equal to e raised to x square. So remember, when we are derivating the first time, you are derivating the first e over here raised to something. We are blinded. We really don't know as of now what the power of e is, but there is some power of e. So the derivative of e raised to x, remember, is e raised to x. So e raised to anything will be e raised to that anything, but into derivative of that anything. What is that anything? That is e raised to x square. Simply after that, you will again treat this e raised to something, so that will become e raised to x square into this derivative of x square again, which is 2x. So you will get e raised to x square into e raised to x square into 2x. Moving on, number 6. You have y equal to e raised to x square upon 1 plus x. So we are going to apply the u by v rule here. So you get 1 plus x into derivative of e raised to x square minus e raised to x square into the derivative of 1 plus x, the whole divided by v square, so 1 plus x whole squared. So that's 1 plus x into derivative of e raised to x square is again e raised to anything is e raised to that, so e raised to x square into derivative of x square is 2x minus e raised to x square into derivative of 1 plus x is 0 plus 1, so that's 1, the whole divided by 1 plus x square. You take e raised to x square common, you get 2x into x, 2x square plus 1 into 2x is 2x and minus 1 in the bracket, the whole divided by 1 plus x, the whole squared. Come to the next sum. Y is equal to 3 raised to x log x. So differentiate that with respect to x. Dy by dx will be, you know that a raised to x is a raised to x into log a. So 3 raised to whatever is 3 raised to that into log 3. So a raised to x into log a. So that's 3 raised to x log x into log 3 into derivative of x log x. That is UV rule. So this continues as it is. This becomes x into derivative of log x, which is 1 by x, plus log x into derivative of x, which is 1. Here this cancels, so you get 1 plus log x in the bracket with 3 raised to x log x into log 3 outside. Now come to the next question, that is question number 8. You have y is equal to log of log x but to the base x. Now remember, in calculus, meaning in derivatives or in integration, you cannot have a base other than e. If you have a base other than e, then you have to change the base. So how do you change the base? Log of a to the base b is log of a upon log of b. So this will become log of log x divided by log of x. And now we treat that like a u by v rule. So when we derivate, we get v, which is log x, into derivative of u, which is log of log x, minus u log of log x into derivative of v, which is log x, the whole divided by v square, which is log x the whole squared. So you get log x multiplied by derivative of log x will be 1 upon log x into derivative of what is inside. So derivative of log x is 1 by x, that's the chain rule, minus log of log x into derivative of log x is 1 by x, the whole divided by v square, log of x whole squared. In this case, this log x and the one which has gone down, these two log x get cancelled. You're just left with a 1 by x here minus 1 by x into log of log x. So we can take 1 by x common, you get 1 minus log of log x in the bracket, you get log of x the whole squared in the denominator, which then can be just simply written as 1 minus log of log x divided by this x into log of x the whole squared. Moving on, question number 9. You have y is equal to log of log x the whole squared. Now this is quite interesting. You have 3 logs and the whole thing is raised to 2. So first of all, when we derivate, we'll treat the whole thing raised to 2, meaning we'll treat it like x square. So it will become 2x raised to 1. So this will become 2 into this whole thing raised to 1. But then into the derivative of this whole thing which is inside, meaning log of log x is derivated ahead. Now log of this will become 1 upon this, so 1 upon log of log x comes here into the derivative of what is inside, so log of log x is derivated, which in turn log of this will become 1 upon that thing in the bracket, so log of log x will become 1 upon log x into derivative of what is inside, which means derivative of log x, which is 1 by x. So this first term, 2 raised to this whole thing raised to 1 remains. Then you have this 1 upon log of log x, then you have this 1 upon log x, and then you have that 1 by x, and that is the answer. Then let's come to the 10th sum. You have y is equal to log of sine cube x into cos raised to 4x into x square minus 1 raised to 5. Now if you were to derivate this outright, it would create a little bit of complications. So what we do is we apply the log properties first. So you know log of ABC is log A plus log B plus log C. That is precisely what we've done here. So log of sine cube x plus log of cos raised to 4x plus log of x square minus 1 raised to 5. Then we bring down the powers. So log of a raised to b you know is b log a. So this becomes 3 log sine x. This becomes 4 log cos x. This becomes 5 log of x square minus 1. We differentiate that with respect to x. now, because now it's become very simple, so we differentiate with respect to x. You get 3 into log of sin x, the derivative was 1 upon sin x, but into what derivative of what is inside, so derivative of sin x, so that's cos x, plus 4 into 1 upon cos x into derivative of cos x is minus sin x, plus 5 into derivative of log of x square minus 1 is 1 upon x square minus 1 into derivative of x square minus 1 is 2x. So what do we get? We get 3 into cos upon sin is cot x. We bring this minus sign back. Minus 4 into sin upon cos is tan x. This is 5 into 2x, which is 10x upon x square minus 1. Let's come to the last sum now. It's an important sum. You have y is equal to log of x plus x square plus y is equal to log of x plus root of x square plus a square. So we differentiate that with respect to x. We get log of the whole thing, which will go down. So 1 upon x plus root of x square plus a square into derivative of this brackets. So derivative of x plus root of x square plus a square. What is that? Derivative of x is 1 plus root of x square plus a square. The derivative will be 1 upon 2 root x square plus a square into derivative of what is inside. Derivative of x square plus a square is 2x plus 0. So we write that there. This 2 and this 2 got cancelled. We take the LCM here. So 1 gets multiplied by root of x square plus a square, plus we have this x here, the whole divided by, you will get this LCM root of x square plus a square. Now you have to keep in mind that x plus root of x square plus a square and this x plus root of x square plus a square would get cancelled, and you would just get 1 upon root of x square plus a square as the answer. I hope you understood these 11 examples that I showed you based on composite functions. There is some more composite functions to be dealt with. Those are dealing with inverse trigonometric functions, so that I will deal with in the next session. Thank you so much for watching.